First question. ठीक है. So in the first question, in Fraunhofer diffraction due to a narrow single slit, a screen is placed 2 meter away from the lens. So here F, this is first question. What is this? F or D, they are providing us as 2 meter. That is 2 meter. ठीक है. This is from the lens to obtain the pattern. If the slit width is 0.2 millimeter, so slit width E, that is 0.2 millimeter. This is given millimeter. ठीक है ना? This is the first question. And the first minima are 5 millimeter on either side of the central maxima. So what they are saying that if you observe this pattern here on the screen, and here we are having single slit. So this is single slit. Light is incident on it like this. It is normally incident, so planar wavefront is incident on it. As a result, you are getting diffraction pattern on the screen. So this type of pattern you are going to get. So this type of pattern you are going to get on the screen, single slit diffraction pattern. ठीक है? This will be. Now what they are saying that first order minima are 5 millimeter on either side of the central maxima. So they are saying that this distance from here to here, from O to this, on this side as well as on this side, this is 5 millimeter. So this distance they are providing us, that is, it is 5 millimeter. Find the wavelength. Find the wavelength, beta. So you have to find out the wavelength. Bataiye how you are going to find out. So this is first minima. What is the condition of minima? Condition of minima is E sin theta equal to plus minus n lambda or m lambda you can write. For first minima m will be 1. So I write E sin theta. E sin theta. This will be equal to, you can say, plus minus lambda on both sides. Okay, here you can observe one thing. Here you are going to observe one thing, that this distance from here to here, this is 2 meter. This is 2 meter. Try to understand this. And this distance is 5 millimeters. So if you draw this angle, theta 1 is going to be very, very small. Try to understand this angle theta 1. This is the angular position of the first minima. This will be very, very small because this perpendicular is in millimeter, 5 millimeter. And this base here, you look, this is 2 meter. This is 2 meters. So 2 meter and 5 millimeters. So this angle will be very, very small. So what can I do here? I can approximate this sine theta as theta. And what will be theta here? Theta will be this. If I call this distance x and this distance as d, so this angle will be roughly equal to x upon d. I can approximate it like this. So this will be E lambda, yeah, Ex upon d. And I'm choosing just one plus lambda. So this will be Ex upon d, sorry. This will be Ex upon d. And this will be lambda. So you want to find out this lambda. Lambda is Ex upon capital D. So E here is given, that is 0.2 millimeter. So this will be 0.2 into 10 to the power minus 3. This X is 5 millimeter. So this will be 5 into 10 to the power minus 3. And here this D is 2 meter. This is 2 meters. So this is 0.1. So this will be 0.5 here. 0.5, or you can write 5 into 10 to the power minus 7. ठीक है ना? 5 into 10 to the power minus 7. This will be meter. So this will be the wavelength. This is going to be the wavelength here. Is it clear to everyone? Hello?
Yes, sir.
So this will be the answer. Answer will be 5000 angstrom. So in options, what answer was given? 5000. If you increase 3 zeros here, it will be 10 to the power minus 10. So you can write it as 5000 angstrom. ठीक है? So this type of question may be there. ठीक है? So different questions may be there. They can give this question in reverse. They will provide you the lambda. I can give you the lambda and I will ask you what will be the width of this central maxima. Now please solve this question in another way. Okay. What I am doing here, I am providing you here this lambda also. So this was the question. I have solved it. Now solve this question. I am providing you this E. E is equal to 0.2 millimeter. 0.2 millimeter. Capital D, that is 2 meter, and wavelength of the light that is used, that is 5000 angstrom. So this data is given, and now find the width of the central maxima. You have to find out the width of the central maxima. Find the width of the central maxima. Find the width of the central maxima. Of the central maxima. How you are going to solve it? Same. Here it will remain same. This will be E sine theta equal to plus minus. Everything will be same. So this time what you are going to find out, you will find out X. So what will be X? This will be D lambda upon E. So this will be X will be D lambda upon E. Now D was 2. Lambda is 5000 angstrom. So this will be 10 to the power minus 10. Minus 10 divided by what was E? E was how much? This is 0.2 millimeter. So this will be 0.2 millimeter here. ठीक है 0.2 millimeter. So 0.2 into 10 to the power minus 3. ठीक है. So this will be 0.1 here. So this will be 10 to the power minus 4. So this will be 5000 into 10 to the power minus 6. So this will be 5 millimeter. But how much it will be? This will be 5 millimeter. So width of the central maxima. Width of the central maxima. Central maxima will be equal to 2x. ठीक है? So what will the width of the central maxima? It will be from here to here. So 5 millimeter is this, 5 millimeter is this. So that will be 2 times. So width of the central maxima is going to be, it will be equal to 10 millimeter. 2 into 5 equal to 10 mm. This will be the width of the central maxima. So this type of question may be there in the exam. Okay? So this type of question you are going to get. Next question, beta. Go to the next question. Now go to the next question, beta. Question number 2. Have you received the questions?
Yes, sir.
Now go through question number 2. That is also single slit diffraction experiment. A beam of light contains a mixture of wavelengths lambda 1 and lambda 2. So incident light is consisting of 2 wavelengths. So incident light here, incident light is having 2 wavelengths, lambda 1 and lambda 2. ठीक है? So instead of monochromatic light, it is bichromatic. ठीक है ना? So 2 wavelengths are there. When the light is incident on a single slit, the first diffraction minimum of lambda 1. So first minima of lambda 1. So this is like this first minima of lambda 1 coincides with second minima of lambda 2 on the same screen. On the same screen, how the two wavelengths are related. So you have to find out how these two wavelengths are correlated. So try to understand on the screen. This is the screen here and you are getting pattern here on this screen. So this type of pattern you are having for one of the wavelength. So this is the lambda 1. Sorry, this is for lambda 1. This is the first minimum. This is the first minimum. And what is happening here? ठीक है ना? It is coinciding with the second minima of lambda 2. So it will be like this. Here you are going to get something like this. You are getting this type of pattern. So it is like this type of pattern. So this is lambda 2 and this is lambda 1. This is lambda 1, this is lambda 2. So second minima of lambda 2 is coinciding with the first minima of lambda 1. So for lambda 1 it will be, try to understand angular position of both are same. So angular position of both the minimas are same. So if you are having a slit here, then you can observe that angular position of both the minimas for lambda 1 and lambda 2, this theta will be same for both. Okay, so I'm writing E sine theta for lambda 1 light, that will be 1 into n is 1 lambda 1. For the lambda 2 light, E sine theta angle will be same, angular position will be same, so this will be 2 times lambda 2. Equate these two equations, what you are getting 1 lambda 1 is equal to 2 lambda 2. So lambda 1 is equal to 2 lambda 2. So this will be the correlation between lambda 1 and lambda 2. In exam, what they do, they will provide you one of the wavelengths. Suppose I say, suppose this lambda 2, okay, lambda 2 is roughly of 3500 angstrom. Then what will be the wavelength of this lambda 1? Okay, this will be 7000 angstrom. So this type of question they can design. Okay, so this is a very good question. These questions, only this simple type of questions they are going to ask. You can look at old questions, PYQs. You will find out most of the questions are very simple. Next question, beta. Next question. This is also from single slit diffraction. A single slit is illuminated by a monochromatic light of wavelength 5600 angstrom. So monochromatic light is there, 5600 angstrom is the wavelength of the light, 5600 angstrom. And diffraction bands are observed on the screen 2 meter away. So again, this D they are saying this is 2 meter, 2 meter, or you can say this is the focal length of the lens. They may say anything. ठीक है ना? 2 meter. If the center of the second dark band is 1.6 meter from the central bright band, deduce the slit width. Deduce the slit width. So this type of pattern is there. So here we are getting this pattern. So you should be, every time I'm making this diagram, the reason is I want to make it pictorially correct in your mind. So they are talking about the center of the second minima. So where will be the center of the second minima? So we just should be very clear about the picture. This is single slit and this is the position. This is first minima. This is the center of the first minima. This is the center of the second minima. So this will be, they are talking about this angle. This is theta 2 actually. Theta 2. Okay? This is theta 2. And they are providing me lambda. And they are saying the center of the second dark band is 1.6 centimeter from the central bright band. So central bright band is here. This is here. This is the center of the second order minima. So this is 1.6 centimeter they are providing. And how much distance is this? This is 2 meter. So again, you can observe this theta 2 will be very small. So what is the condition of second minima? This will be E sine theta. This will be E sine theta 2. Okay? E sine theta 2. This will be second order is there. So I'm writing 2 lambda. 2 lambda. You want to find out this E. So here this E, this will be approximated at theta 2. So this will be roughly at theta 2 and this will be 2 lambda. Theta 2 will be how much? I say this distance is x2. x2. So it will be ex2 upon capital D. Angle equal to arc and this will be the distance 2 meter. 2 meter is very, very large as compared to 1.6 centimeter. So I can use like this. So what will be E? This will be 2 lambda D upon x2. So here it will be 2 into 5600 angstrom into 10 to the power minus 10 meter. I converted and this is 2 meter and 1.6 centimeter. This is 1.6 into 10 to the power minus 2. Okay? So this will be minus 3 here. Okay, na? 2 and it will become 10 to the power minus 3 here and this will be 8 times. This will be 4 times and this will be 4 1 ja 4, 4 4 ja 16. This and this will be 10 to the power minus 7. Okay? So if I consume, so this will be 140 micrometer. Okay, na? So it will be roughly, it should be 140. I can check the answer of this question. Is it okay? Yes, this will be, this is 0.14 millimeter. This is 0.14 millimeter, 10 to the power minus 3. So it's okay. ठीक है, they are saying answer is 0.14 millimeter. 14 millimeter. So 0.14 millimeter this will be. So here if you use 4 power 10 to power minus 4 power here, so it will be point here and 10 to power minus 3 will be there. So this is okay. 140 micrometer. 140 micrometer. This will be the answer. You can check. Is it okay with everyone? Hello.
No,
Yes, beta?
no, sir, it's fine.
Okay. Next question, beta. First is what are missing order? That's okay. I have discussed in the last class. Deduce the missing order for a double slit diffraction pattern. So next question, question number 4, that is related to double slit. Double slit. Deduce the missing order for a double slit diffraction pattern if slit widths are 0.16 millimeter. So they are providing me slit width that is कितना दिया है point कितना दिया है बेटा this is 0.16 millimeter 0.16 millimeter this is E. Second, they are 0.8 millimeter apart. They are 0.8 millimeter apart. So 8 millimeter apart means they are providing me E plus D. So this will be 0.8 millimeter. So what will be the missing order? What is the condition for missing order? This will be you can write E plus D upon E, and this will be N upon M. So these are the order of missing interference maximas. This will be the order of missing interference maximas. Interference maximas. This will be, okay? So I want to find out N. So N will be how much? This will be E plus D upon E, and this will be M. And what will be M? M will be corresponding to first order minima, second order minima, third order minima. So you can write here M is equal to actually plus minus 1, plus minus 2, plus minus 3. They will be like this. So what will be the missing order? Missing order E plus D is 0.8. I am writing it as 0.80 divided by E. This is 0.16. So this will be 5M. 5M. So which interference maximas will be absent? This will be plus minus 5, plus minus 10, plus minus 15, like this. These interference maximas will be absent. So here fifth order will be maximas. This will be the missing order. Can you tell me how many interference maximas will lie inside the central maximus? Within the not within the central envelope. Within the central envelope, how many interference maximas will exist?
9.
They will be 9. Very, very good, beta. Okay, they will be 9. I can show you here just to explain you the question. Your answer is correct, beta. So you are going to have this type of pattern in diffraction envelope. So now, so here, this will be 0th order. Is it visible? White color is visible, beta?
Yes, sir.
Yes, sir.
This is first. So here, 1, this will be there. 2 will be there. 3 will be there. थोड़ा सा और ज़्यादा बनाना था. And fourth and fifth will be here. That will be missing. ठीक है. Similarly here, they should be equally spaced, so you can shift a little bit on this side. So this should be the first one. This should be the second one. This should be the third one. This should be the fourth one, and fifth will be here. So this is 5 that is missing. So this 5 is missing. Here this will be minus 5, that will be missing. So 0 is here, plus 1, plus 2, plus 3, plus 4. Exactly similar type of question they asked last year. So this will be minus 1, minus 2, minus 3, minus 4. So here number of maximas inside the central envelope. Number of maximas inside the central, that is 4 plus 4, 8 plus 1, 9. Can you tell me how many minimas will be there? How many minimas will be there? So look here, 1, 2, 3, 4, 5, 6, 7, 8, and this is here. This is like this. So that will be number of minimas will be 1 less as compared to maximas. As compared to maximas, minimas will be 1 less. So number of minimas will be equal to 9 minus 1. That will be 8 beta. ठीक है ना, that will be 8. Actually this minima, try to understand, this minima is actually here. ठीक है, this is minima here. So it will be like this. So exactly similar type of question they asked last time in the last exam. So you can look at the last question in your sheet. I will again continue from here, but go to the last question on the sheet. Look at this question.
Could we go to the previous slide, please?
Just 1 second, beta. I will show you. Just first go to the last question of the PDF I shared. For a two slit Fraunhofer diffraction, each slit is 0.1 millimeter wide and separation between the two slits is 0.8 is 0.8 ठीक है millimeter. The total number of interference minimas between the first diffraction minima on both sides of the central maxima is. बोलिए, what will be the answer? In that question, what they are saying that this E is equal to how much? E is equal to 0.1 millimeter. So I am using another. So E is equal to 0.1 millimeter, 0.1 millimeter here. ठीक है, next E plus D. They are providing us 0.8 millimeter. So here, what will be the missing order? Missing order will be E plus D by E, and that will be M here. So this will be 0.8 by 1. So this will be plus minus 8 plus minus 16. ठीक है, like this. So how many maximas will be there inside 7? This will be, बोलो बेटा कितना होगा? How many will be there? So this will be
15 maxima and 14 minima.
15, and this should be actually, this should be what I have counted here. Just check it. This will be 1, this will be 2, this will be 3, this will be 4, and I'm drawing here, it will be like this actually. So whatever maxima is missing, that will be like this. ठीक है, this should also be counted. So this will be plus 1. Sorry beta. Here make it correct. This is 9 plus 1. So this will be 10, not. So that's why it will be like this. This should be 10 beta, not minus 1. Actually, try to understand, this maxima is here. So this will lie inside. So this was the missing one. ठीक है, so this is the missing one, but this minima will be inside. So this should be 10. 9 plus 1, this should be 10. So please make it correct. Similarly, 1, 2, 3, 4, 5 is here, and 1, 2, 3, 4, and missing was here, but minima will lie inside. ठीक है, minima. So this will be 9 plus 1, this should be 10. So it will be here 7 to the 14 and 15. So this will be plus 1. So it should be 16 beta. So your answer should be 16. Please make it correct. So 16 will be the answer here. So what will be the answer? That will be 16 beta. So go for it. Is it okay? Hello?
Yes,
Please
sir.
make it correct. This will be plus 1, not minus 1. Just 1 second. This will be. Next question. So this type of question was there in the exam. Now go for the next question. Look at this. This question was also there in the exam. Next, the maximum number of intensity minima that can be observed again that can be observed in the Fraunhofer diffraction pattern of a single slit width is 10 micrometer. So what is the width? 10 micrometer. That will be 10 micrometer. Illuminated by a laser beam of wavelength 0.630 millimeter. Lambda is 0.630 millimeter. This is millimeter. This will be 4 options are given: 4, 7, 12 and 15. So you have to tell me how many minimum number of intensity minimas that can be observed in Fraunhofer diffraction. You have to tell me how many diffraction minimas he's talking about. How can you find out? So earlier, please look at this. ठीक है, please note it down. Some student was saying.
Thank you.
Welcome. So here this were 9 plus 1, this will be 10. This is okay now. So this is E plus. Can you tell me how many maximum number of minimas you can observe in the pattern?
सर
Yes, beta, please.
सर प्रीवियस क्वेश्चन में वो 15+1 वो 15 थोड़ा सर कंफ्यूजिंग कर रहा है.
No, देखो, this is not. Try to understand which one is missing. This 5 is missing. ठीक है ना? This 5 is missing, and here this -5 is missing. So how many maximas will be inside? 0 will be there. This will be extra, and this will be 1, 2, 3, 4. ठीक है? 4 are here. 4 are here. Plus 1. ठीक है? 4 plus 4 plus 1. This will be 9. That is okay. For maximas, there is no problem. ठीक है? Most of the time they ask about this maxima. But how many minimas will be there? How many minimas inside will be there? So I was also a little bit confused at that time, but try to understand. This is the missing one. I have drawn here. This will not be there. This will not be there. So 5th is not there, but try to understand one more will be there, because any maxima, try to understand any maxima, it will be surrounded by 2 minimas. And if you are having 2 maximas, there will be 3 minimas. If you are having 3 maximas, there will be 4 minimas. There will be 4 minima. So here, how many maximas are there? There are 9. So one minima will be one more. And you can count from here. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 will be here. So 10 will be here. So this will be 9 plus 1, 10. Even I can make one more here. ठीक है? Just suppose I'm drawing one more diagram. You can count. Suppose missing order is, I say 3. I'm saying suppose missing order is 3. That's why I say that every time we should make the diagram so that it will be more visible. So here, this is 0th order. Third order is missing. Suppose I am assuming missing orders are plus minus 3, plus minus 6, like this. So here thirds will lie here. So this is the central one. This is plus 1, plus 2. Third will be here, and it should be here. And this is the missing one. Try to understand, this is the missing one, but minima will lie inside. Here at this point, who is falling here? Who is falling? Maxima. So this minima will be here inside. So here it will be 1. This will be 2. This will be 2. And here it should be 3. and this is missing one. But this minima is inside. If you count the minimas here, this will be 1, this will be 2, this will be 3, this will be 4, this will be 5, this will be 6. So 6 minimas are there. And how many maximas are there? Maximas equal to 5. 2 plus 2 plus 1, that will be 5. And minimas, this will be one more. This will be 6. 5 plus 1, 6. Is it okay now, beta? Hello?
Yes, sir.
So one more minima will be there. Okay, even this aspect will be there in grating also. In grating also this aspect will be there. Next question, but whatever I was discussing. So E is given, lambda is giving, and we have to find out maximum number of intensity minima. So maximum number of intensity minimas you want. Can anyone tell me? So for this, you have to understand this angle theta, diffraction angle theta here. So here it will be like this. This is the screen. And light is diffracted like this at some angle theta. Can you tell me what can be the maximum values of theta from where to where this theta is? So on this side, it will go up to plus 90 degree. Okay? Plus 90 degree. So this theta should be less than pi by 2. And it should be greater than minus pi by 2. Because when you measure angle in the clockwise direction, this will be minus 90 degree. So this will be the value of theta. So maximum value you can choose for theta here is 90 degree. 90. Theta will be less than 90. So maximum value I can choose, that is theta. Theta here. So this will be E sine theta equal to n lambda. I want to make this n maxima, so this sine theta should be maxima. If you want to make it max, because lambda and E are fixed, so this should be max or corresponding to the maximum angle 90 degree on one side. So it will be E sine 90 degree, and this will be n max lambda. So what will be n max? N max will be E upon lambda. So E is how much? E is 10 micrometer. 10 micrometer, 10 into 10 to the power minus 6 divided by 0.630 into 10 to the power minus 3. ठीक है? 10 to the power minus 3 beta. So both are micrometer, I think. They are both are micrometer here. Both are micrometer. So I was looking, that order is not matching. So this will be 10 to the power minus 6. Now you can count. Okay. This will be E upon lambda. Calculated 10 upon 0.630.
15.
Roughly 15.87. 15.87. So what is the order? Order will be 15 actually. Beta. Okay. Order will be 15, means 16 is not appearing. The meaning is 16th minima is not appearing. So how many are appearing? 15 are appearing. Okay, na? 16 is after this. 16 will be formed beyond 90 degree. So that is not appearing. Angle cannot be more than 90 degree for diffraction here. So maximum order will be 15. So this will be the answer. This is the answer of this question, 15. So this was another question. Now go to the next one. Go to the next one button. Monochromatic light of wavelength 633. Lambda is 633 and nanometer falls on a slit if angular separation between the first minima of intensity on either side of the central maxima is 19.5 degree. 19.5 degrees. So what they are providing us? Angular separation. So this time they are providing us this angle. Here you are having the so this is theta 1. This is theta 1. So what will be the angular separation between first order minima on the both sides? So this is also theta 1. So what is the angular separation between the first order minima? Angular separation will be this one. This will be the angular separation between two first order minima. So 2 theta. 2 theta 1 is given to us. How much it is? 2 theta 1 is 19.5 degrees. 19.5 degrees. So what will be theta 1? Theta 1 will be 19.5 divided by 2. So 9.75 degree. Now what we have to find out? Slit width is approximately. So slit width approximately E sine. Apply the condition of first order minima. E sine theta 1 equal to lambda 1. Okay, E you have to find out. Lambda 1 is 633 nanometer divided by sine 9.75. This is in degrees. Find out, beta.
Sir,
Yes, beta, please.
question में angular separation on either side of the central maxima दिया तो सिर्फ theta 1 19.5 degree दिया?
नहीं, if angular separation between the first minima of intensity, so it is between the first minima of intensity on either side of central maxima. So this one is there, this one is there, and angular separation is given between these. ठीक है?
Okay, sir.
So a little bit language is there, but they are talking that between these two, ठीक है? Angular separation, and they are saying first order minima on this side and first order minima on this side. So this will be, calculate this, how much it will be. This comes out to be, you please check it. This should be 3.7 into, so here write it 10 to the power minus 9 and calculate it. This will be 3.7 into 10 to the power minus 6. Meter or 3.7 micrometer. In exam, they will give you some angle. ठीक है ना? Either they are going to provide you this one. ठीक है? They will provide you this one, or you can use whatever data they are providing you. They will provide you some data so that you can find out sine theta, or you can use the calculator that will be available with you at that time. So
Sir,
this will be, yes beta, please.
वो पहले दो क्वेश्चन में आपने थीटा को अप्रोक्स किया ना, साइन थीटा को एज थीटा
Yes beta.
फॉर वेरी स्मॉल थीटा, तो मतलब कितने ऑर्डर तक वो कंसिडर कर सकते हैं, ऐसा कुछ है क्या?
No, actually it's not like this. There is nothing, but try to understand this is 2 meter. ठीक है? Here suppose it is 1 centimeter. ठीक है? Roughly try to understand. And here this is 2 meter. So 2 meter means if you convert meter into centimeter, how many centimeter will be there? 200, no? 200 centimeter. So try to understand this angle will be very, very small. These are 200 units. This is only 1 unit. So it will be very, very small. Is it clear?
Okay,
So
sir,
this,
yes.
but exactly no one can tell you how many centimeters should be here, but approximately we have to use this. ठीक है ना? So, but if it will be 10 to 20 centimeter, suppose it is 20 centimeter or 30 centimeter, then I will try to find out the angle. In
Okay.
that case, I'm not going to use the approximation. So this is just an idea, but no set rule is there where you are going to use this type of approximation.
Okay, sir.
Next question. Yellow light of intensity I naught. So there is yellow light of intensity I naught is used in a single slit diffraction experiment with slit width 0.6 millimeter. So what is E? 0.6 millimeter. If yellow light is replaced by red light of same intensity, now they replace this by red light, but they keep intensity same. Then observed pattern will reveal. ठीक है ना? Then new pattern will have that central maxima is broader. You have to tell me central maxima will be broader or not. बोलिए. So from here I can show you. This is single slit experiment. You are changing the wavelength. What you are doing here, you are changing the wavelength, and pattern will be broader or narrower, you have to find out. So here you are having the pattern. So I am just using first minima. So this will be theta 1. This is theta 1. ठीक है, I will use theta 1. So this will be E sin theta 1 equal to lambda plus minus lambda, but I'm using lambda only. Now theta 1 approximately it will be x1. I will write x1, and this will be d. So I can write E. I'm approximating it by x1 by d, and this will be lambda. So what will be x1? This will be d lambda upon E. Now, what you're doing here, wavelength of the yellow light is lambda y. For red light, it will be lambda r. Who is greater? Lambda r is greater than lambda y. ठीक है? So D and E will remain same. So you will have, if you are having yellow color, it will be d lambda y by E. ठीक है? So what will be x1 for yellow color? This will be d lambda y divided by E. And what will be x1 for red color? This will be d lambda red upon E. Who is greater? Lambda r is greater. So x1 r is greater as compared to x1 y. So what will happen to this pattern? This pattern will become broader. So central maxima is broader. So first option, that central maxima is broader. So here, if you are using red color, then central maxima will be something like this. You are going to have this type of pattern. ठीक है? So it will become more broader. ठीक है? So ये थोड़ा narrower बनाया था. It will be something like this. It should. ठीक है? It will be. So central maxima will be broader. Option A is correct. Intensity of the central maxima reduces. Option B. What is the intensity of the central maxima? Can anyone tell me? Intensity of the central maxima. I was equal to a square. ठीक है, a square this depend upon the slit. ठीक है, slit. So here this is sine square alpha upon alpha square. Alpha square, if you are changing what is I naught will be, ठीक है, for alpha tending to 0, you take the limit of this and what you find out, intensity of the central maxima is a square. So either you are using yellow light or you are using red light, intensity of the central maxima will remain same. Okay, intensity of the central maxima is not going to change. So intensity will remain same. So option B is wrong. So option A was correct. Option B is wrong. ठीक है, option C, intensity of the maxima remains same. Yes, intensity of the central maxima remains same. This is now first minima appears at higher angle. Okay, first minima will surely appear at the higher angle because it is becoming broader. Okay, so now for the red color, first minima will appear at a larger angle. Okay, so here this is for red light. This is for yellow light. For yellow light, here you are having minima at an angle θ1, but for red light it will be here. So this will be θ1 for red light, and this is for yellow light. So option D is also correct. So A, C, and D, A, C, and D, these three options were correct. This was MSQ. Okay, this question was MSQ type of question. So this will be width of the central maxima is proportional to lambda. Here you can write, okay, width of the central maxima is proportional to the wavelength of the light. Width of the central maxima is proportional to the wavelength of the light used. This question was there in the exam. Please solve the next question. Yes, beta, please.
Proportional to
Is proportional to wavelength of the light used. The width of the central maxima will be proportional to the wavelength of the light used. So the width है ना, this width, ठीक है ना, this width, this is the width for yellow light. And for this, for red light, this will be the width from here to here. So this will be for the red light. So this width will be proportional to width of the central maxima will be proportional to lambda. You can write like this. Next question. Go through the next question and you can solve. Tell me what will be the separation between slits. Please try to solve this question. I'm modifying this question. Try to understand. Please solve this question in a different way. I'm giving you a pattern. This is double slit diffraction pattern. Please solve this question in another way. I'm giving you a pattern. So you are having this type of pattern. So you are having this type of pattern. This will be this pattern will be symmetrical on both sides. So they are providing you, suppose, this pattern. One, two, three, 4, 5, and 6 is missing. Okay, and then they are showing like this. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. It will be like this. Okay? Suppose this pattern is given to you. Now, width of the slit. I am providing you the slit width. Slit width. Slit width is suppose equal to 0.3 mm. And my question is, find the separation between two slits. You have to find the separation. Find the separation between two slits. Find the separation between two slits. Please find out. Do this question. Find the separation between two slits. बोलिए. This is a very simple question, but good question. Find the separation between two slits.
0.6 millimeter.
Just let me check. So who is missing here? This is 1 is here, 2 is here, 3 is here, 4 is here, 5 is here. Who is missing? 6th is missing. It means E plus D by E. This will be 6 upon 1. Okay, for the first minima. First minima will lie at the 6th interference maxima. So E plus D you have to find out. So this will be 6 times E. So 6 into, this will be 0.3 millimeter, 1.8 millimeter. ठीक है ना? This should be the answer.
सर
This, yes, beta, please.
क्वेश्चन में वो थर्ड मैक्सिमा भी
No,
मिसिंग
no, no.
बोला था.
I have modified that question. This was the question. This pattern is given, suppose, and slit
Okay,
width
okay.
is 0.3 millimeter. ठीक है?
Yes.
Then you have to find out the separation between two slits. ठीक है? So this type of pattern, in this pattern you have to recognize which interference maxima is missing. So from the missing one, you can write this equation and you can find out this will be 6 times 1.8 millimeter. And the question that was given, उसका answer था बेटा 0.9. Whatever question was given, in that question what was given, third, which was absent, absent. So in that case, it was E plus D by E. That will be 3 by 1. So E plus D in that case will be 3E. So this will be 3 into 0.3. 0.3. So this will be 0.9 millimeter. Okay, this is the question on the sheet. And this is the question I have given you here. Okay. Next two questions you think, okay na? Particularly the last one, this question, 2016 question. Look, try to understand these questions. I will start in the next class from these two questions. Please try to think. This will be very helpful, particularly this question that was asked in 2016. Okay? So I will start from here. So that will be very good. Very good question that is. Okay, beta. So please save these slides. This is first one. This is first one. Second. Third. fourth, fifth, sixth, seven, eight, nine, 10, 11, 12.
सर,
Yes, beta, please.
आपने वो जो लास्ट क्वेश्चन बोला ना देखने के लिए,
Yes, beta.
उसमें क्या ए एंड डी सही ऑप्शन है क्या?
Yes, beta. A and D. ठीक है. In 2016 question, A and D are the correct option. In 2024 question, third option is correct. ठीक है. You have to think about these questions. And then I will start from here and then I will discuss diffraction grating. So in the next class, I will discuss diffraction grating.
थैंक यू सर।
Welcome, beta.
Thank you, sir.
Welcome, beta.